Hello, I'm Thomas O'Rourke, and I'm a tutor sponsored by the Office of Student Success for TSDC's AC Circuits. Today we're going to be going over the AC Circuits class offered at TSDC. Our topics are going to be electromagnetic fields, intro to alternating current, capacitors, inductors, transformers, and circuit setup. Right here we see a permanent magnet, and these blue lines are the electrical magnetic field. The electromagnetic field interacts with other magnets. As you can see from this presentation, we have north, south on the top against a north-south. They aid each other, and the magnetic fields combined and get stronger. On the bottom of the slide, you'll see that if you put north to north, that they react against each other, and they do not combine. When also studying electromagnetic fields, they discovered that if you run electricity through a conductor, it creates its own electromagnetic field. Electromagnetism can be used to power things such as solenoids. Right here you see on the left we have a solenoid in its enclosure. Then you remove all the outer casings, and it's a wire or a coil over the inner diaphragm that holds two magnets, which you'll see at the cutaway view. In its normal state, a spring will hold the two magnets apart, leaving the solenoid open or extended. Once electricity is powered through the solenoid's coils, it interacts with the magnets because the electromagnetic field produced, and it retracts and compresses the spring. Another device that uses an electromagnetic field to operate are relays. Here's a basic relay where you see the outer coil around the enclosure. With a cutaway view, you see that there are two contacts that are open. Once the electric magnetic field energizes the coil, the two pieces of metal are also energized, and they snap together, completing the circuit, so that electricity will be able to pass from one side and through the other. Another popular application of magnets we use today are in speakers. We see here is a basic diagram of a speaker, where you have the coil, which is what creates our electromagnetic field, and a permanent magnet. When the coil gets an input from your radio or CD player, it interacts with the magnet and causes the cone to vibrate and create sound waves. Another application of magnetism you might not be aware of is in the reading and writing of your CD-ROMs. For your music or your games, the industries will use magnets, which you see right down here, along with your laser beam to write data onto a CD-ROM. When the coil is energized one direction, it will input data. When it is energized in reverse, it will erase data. So that's how you get all your information on a CD-ROM. It's a good thing we have magnets. One of the most important discoveries while studying electromagnetic fields was that we can induce voltage. The idea of inducing voltage is when you take a magnet, as you can see here, with a south and a north, so this is your magnet, and you run it through a coil of wires, which, as we discussed, can have its own electromagnetic field. When the magnet interacts with the magnetic field of the coil, it produces a voltage. As you can see, it is moving slowly in this diagram, so there's a little bit of voltage produced on that voltmeter, and on this side it is moved rapidly, which creates even more voltage. After discovering how to induce voltage, we were able to apply that theory and create generators. Here is a simplified picture of a generator with a north and south magnet, and you can see the magnetic field in the inside represented by the blue lines. And then a wire is spun around the inside of the magnetic field, which will then produce electricity out of these two leads. Thank you for watching. This is Thomas O'Rourke, tutor for AC circuits from TSDC, sponsored by the Office of Student Success.